Hello everyone, hope you are doing well. Welcome to the online platform Civil Techno Bricks. Guys, here we will tune for the instantaneous decoding of conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Guys, today we will see the core concepts related to the atmospheric window in remote sensing. Here, the atmospheric windows in remote sensing is nothing but the physics of transmission and the engineering of satellite sensors. Here, the design of every Earth observation by the satellite is dictated by a signal physical constraint that which the selective opacity of our atmosphere. Here, with reference to the atmosphere, the scattering and absorption both combinedly work or held with reference to that atmospheric zone where the satellite sensor is playing the role of detector. Here, the satellite sensor playing the role of detector and which is emitting the rays. That whole rays are traveling through the instantaneous field of view with reference to the atmospheric window, where the n number of gaseous molecules or particles or cloud-like structures playing the role of obstacle where the incident rays at the atmospheric windows are gets diverted or reflected. Here the incident sunlight which is in the opposite direction, that also incident in the atmospheric layer. Here the atmospheric windows are wavelength regions where that electromagnetic radiation passes through the atmosphere with minimum absorption and scattering. These windows allow that remote sensing sensors to effectively receive reflected and emitted energy from the earth surface. This representation explores how engineers exploit specific spectral windows to observe the planet. So atmospheric windows are most essential because several atmospheric gases, they play the role of block or obstacle or weaken the specific portions of the electromagnetic spectrum. That is, these are the circles. These are all the atmospheric gases blocks. Here, with reference to civil engineering point of view, the atmospheric windows enable accurate acquisition of satellite data for infrastructural planning and environmental monitoring purposes. Here, with reference to the atmosphere as a sensitive, or we can say that the selective filter, that is the interaction of electromagnetic radiation with the atmosphere. Here, the three ways are there, or three types of scattering. Radiation does not travel unimpeded, where it interacts with the medium through two primary mechanisms. Two primary mechanisms are the scattering, and second one will be the absorption. Here, the scattering is nothing but the diffusion of radiation by particles, where relay scattering affects short wavelengths, that are the blue sky, while mass scattering affects wavelengths equal to the particle size. Likewise, then next one will be the absorption. Here this is the phenomena where the loss of energy based on the quantum theory, where the gas molecules, these are the gas molecules, possess discrete energy states. When photon energy matches these states, the signal is absorbed. Here the incoming photons are in this direction, where the scattering, relay scattering, is that gas molecules. If the gas molecule is there, then we observe the relay scattering. For dust and smoke type of particles, we see that type of scattering. And for incoming photons or water droplets, there will be a actual reflection in equal direction. Here, with reference to the absorption point of view, we see the incident incoming photons. At the same time, that all photon energy matches the molecular energy state where signal absorbed by the carbon dioxide or water absorption. So water vapor, ozone, carbon dioxide and dust particles, these are all the major atmospheric constituents which affects the energy propagation. Here we see only selected wavelength intervals, they can allow the maximum transition or transmission and form atmospheric windows. So civil engineers utilize that type of windows to obtain high quality imagery for watershed management, transportation planning and urban mapping or purposes. Next, most important, that is atmospheric window definition. So the definition which is based on the spectral range, or we can say that the electromagnetic spectrum, Likewise, that will be divided into atmospheric bands, or we can say that the absorption bands. They are block bands and most of the transparent bands. So atmospheric windows, which is divided into two parts: block 1, which is in gray color, and transparent, which is in white color. So here a spectral range where the atmosphere is relatively transparent, allowing radiation to transmit between the earth's surface and the sensor. This is the actual definition of atmospheric window, where the remote sensing is only possible in these specific spectral intervals. The spectrum is not a continuous resource, it is a resource of islands. So here the infrared region is, microwave region is noted with reference to the gray color. There are the block absorption bands. On other hand, there are so many bands are there with reference to transparent point of view. They allow to transfer the spectrums. So surface features such as road, building, vegetation, water bodies, they can be effectively identified within these type of regions. So civil engineers use the application point of view this phenomena for urban mapping and transportation zoning or corridor study point of view. So here most important, that blue, green and red wavelength bands are commonly used in optical remote sensing systems so that they are more visible. Next, the important, that is the three primary domains of transmission. Here the electromagnetic radiations are divided with reference to gamma rays, X-rays, then zone 1, zone 2, zone 3 likewise. So zone 1 reflected infrared, zone 2 thermal infrared, and zone 3 microwave rays, where visible and reflected infrared and thermal infrared are marked with reference to microwave. With reference to that zone 1, 2, 3, we check that the gamma rays, X-rays are completely blocked. Gamma rays and X-rays are completely blocked. Fortunate for biology but useless for surface sensing. So gamma rays and X-rays are not feasible for taking the data for surface sensing, but we can use it for biological purpose, just like calculating the or taking the X-rays of any data. We focus on three habitable zones of sensors, that are reflected solar, emitted thermal and microwave. They are reflected solar, emitted thermal and microwave. These are all the three zones. So with reference to that three zones, we check the near infrared window 0.7 micrometer to 1.3 micrometer, and it experiences minimum absorption atmospheric interference, where the healthy vegetation strongly reflects near infrared radiation. That water bodies absorbs most amount of incoming energy. This is the actual domains of transmission of energy. Next, the most important point, which will be the absorbing gases. So here atmospheric absorption by molecule, where the wavelength with reference to the percentage of transmittance. Here the shortwave infrared atmospheric window, here the shortwave infrared atmospheric window occur between 1.5 to 1.8 micrometer and 2 to 2.5 micrometer, where atmospheric transmission is relatively high. With this high transmission, we check the spectral regions. They are more sensitive with reference to the moisture content, mineral composition and rock characteristics. That is, geological structures, weathered zones and soil conditions can be effectively analyzed by using shortwave infrared atmospheric window. So the civil engineering point of view, we are using that for the application point of view, where we have to check the site selection criteria with reference to that absorbing gases, then foundation investigation or subsurface geological investigation point of view. Next important point, that is the atmospheric transmission spectrum. The atmospheric transmission spectrum, which is the fundamental roadmap of remote sensing. The data collection is restricted to the white space under the curve. Here the white space under the curve, that area is restricted. The gray areas are invisible. The all gray areas are invisible and white areas are restricted. So that blue type of area is available for checking. So here the thermal infrared atmospheric window, they are occur mainly between 3 to 5 micrometer and 8 to 14 micrometer, which allowing emitted thermal radiation to reach sensors or to collect the data. So here that thermal sensors measure surface temperature variation and the heat distribution patterns. Means that thermal imagery which more helpful to identify thermal anomalies, moisture variations and urban heat island effect. So that point of view, the civil engineers, they are more reliable and they apply the thermal data in environmental studies, reservoir monitoring and infrastructural maintenance point of view. Here we see the engineering design, that is the multispectral concept. Here the microwave atmospheric window which is seen with reference to the multispectral sampling, that will be in the discrete format. Here we see that discrete format with reference to some color code, but actually that all colors are in the visible spectrum. Means that the multispectral concept which is based on the sensors, they are designed because of that atmospheric window. A satellite band is essentially a physical filter that only admits wavelengths that known to pass through an atmospheric window, where we have to place a band in an absorption region would result in zero signal from the ground. So active microwave systems such as radar, synthetic aperture radar operate effectively within these atmospheric windows, where the civil engineering applications that include the disaster management point of view, flood mapping point of view, landslide detection point of view, or any deformation and monitoring point of view, we use it for the application purposes. Then the thermal challenge. So thermal challenge is nothing but the actual thermal window with reference to the wavelength relationship. So here temperature of the ground is not equal to the brightness of the band 10. That is the actual relationship which is explained with reference to that temperature and brightness level, where even windows have some dirt on them. So band 10, band 11, these are two types of band, and the target signal which is at the ground surface. With reference to that, we take the thermal challenge and we check the thermal activity or the changes with reference to the atmospheric absorption bands. So atmosphere absorbs slightly even in the 8 to 14 micrometer range by measuring that same target in two adjacent thermal bands. So two bands thermal windows, that is wavelength in the micrometer, we can mathematically estimate and remove the atmospheric interference. So certain wavelengths are strongly absorbed by atmospheric gases, creating absorption bands unsuitable for remote sensing observations. So where that water vapor absorbs radiation, then ozone significantly absorbs ultraviolet radiation, protecting the earth's surface from harmful energy. Next, the most important, that is the atmospheric correction. Here the atmospheric correction which is related to the source of light, then the satellite and the terrain element, where the source of light which emitting the energy source sunlight in terms of E towards the earth's surface, and the amount of reflected energy that will be collected by the satellite in terms of total radiance. Here the path radiance with reference to the atmospheric window point of view, we relate the source of light with reference to the reflected detector or the satellite. So here the even in clear windows scattering adds haze to the image. Just like that, if clear atmosphere is available, then also we have some path radiance. Likewise, that atmospheric correction is much needed, or that is the mathematical process of removing this type of haze to retrieve the true surface reflectance. So we want true surface reflectance, so that the atmospheric corrections we have to implement. That atmospheric corrections with reference to the remote sensing point of view, they are designed to operate with the maximum signal transmission. With reference to that satellite spectral bands, they are carefully selected to avoid absorption region and enhance information extraction, where the proper hand, or we can say that the proper band selection which improves image quality, classification accuracy and interpretation reliability also. So with reference to civil engineer point of view, we are using that type for the precise mapping, monitoring and decision making procedure. Next, that is the summary point of view. We are dependent on the three parts: constraint, opportunity and solution. So here the process or the application of atmospheric window in the civil engineering point of view, that will be followed by the workflow from source to the data. So sun, which is a radial source of energy or the right. With reference to that heat or thermal heat, the atmospheric filter will be there where water vapor and carbon dioxide absorption will occur, and that will be collected by the sensors with reference to the atmospheric correction and atmospheric window, so that we collect the data and we present it on the basis of constraint. That will be the atmosphere is selective filter dominated by water vapor and carbon dioxide. Opportunity, we have that observation is restricted to optical, reflected, infrared, thermal and microwave windows, so that the sensors are engineered with spectral bands that precisely match these windows. So that visible and infrared windows support urban mapping, planning, transportation engineering and land use mapping, so that these thermal windows assist in environmental assessment, heat loss studies and reservoir investigations point of view. So knowledge of atmospheric windows allows civil engineer to select appropriate remote sensing dataset for efficient project planning and management point of view. Stay tuned guys. Happy learning.